Okay, here we are with the Geometry and Data Interim Assessment 3 study guide, and I'm going to work my way through the study guide to make an answer key. First problem, the first section is about right triangle trigonometry. Number 1 says a pole is supported by a rope staked to the ground 42.7 feet away. The rope makes a 29.6 degree angle with the ground. Find the length of the rope and the height of the pole. So I'm going to call the length of the rope y and the height of the pole x. In order to solve for the height of the pole, I'm going to look at the angle given and see that that is the opposite side, and I have the adjacent side. So at the top of my paper, it probably would be helpful if you wrote in SOHCAHTOA. So if I'm looking for the opposite and I have the adjacent, I'm going to use tangent. So the tangent of 29.6 equals the opposite over the adjacent. To finish solving this for x, I would multiply both sides of the equation by 42.7. And in my calculator, just enter in 42.7 tan 29.6. And I get that the height of the pole is 24.3 feet. Okay, if I want to solve for the length of the rope, I called that y in relation to the angle given. That's the hypotenuse. I have the adjacent and I need the hypotenuse, so I'm going to use cosine. So cosine of 29.6 equals the adjacent, which is 42.7, over the hypotenuse. Now this problem here is a little different because I have the variable in the denominator. One way to solve this is to put the left side of the equation over 1 and think of using cross products. So I have y times cosine 29.6 equals 1 times 42.7, which is 42.7. To finish solving for y, this is joined by multiplication, so I would divide both sides by cosine 29.6, and I would get y equals whatever 42.7 divided by cosine 29.6 is, and I get 49.1. And that makes sense. The hypotenuse should be the longest side of a right triangle, and that's my solution for number 1. Number 2, it says in the diagram below, I've got two triangles that are right triangles that are similar. If YT is 17, so I'm going to start marking this triangle up right away, and Y is 15, what is the measure of angle A to the nearest degree? Well, if I know that these triangles are both similar triangles, then I know that corresponding angles of similar triangles are congruent. So since angle A is between the short leg and the hypotenuse, I know it corresponds with angle T in the other triangle. So if I can solve for angle T, I will also know the angle for A. So I am going to set up a relationship in regards to angle T. I have the opposite side and I'm looking for the hypotenuse. So I'm going to look for sine is opposite over hypotenuse. So I have the sine of angle T, which is the same as A, is equal to the opposite, which is 15, over the hypotenuse, which is 17. When you're solving for a missing angle measure, you want to make sure to use inverse sine. So we're going to have the inverse sine of 15 over 17 is going to be equal to the measure of angle T. And in your calculator, if you press second sine 15 divided by 17, you get that that angle measure is 61.9 degrees. It says to give your answer to the nearest degree, so I'm going to round to 62 degrees. So angle T is congruent to angle A, which is the measure of angle A. Actually, I should just say that measure of angle T is equal to the measure of angle A, which is 62 degrees. And that's my solution. Number 3, sorry to jump around a little. This is my first recording. Number 3, the two acute angles of a right triangle have a degree measure of x and y. If the cosine of x equals 7/25, what is the value of sine y? Well, the neat thing about right triangles is that I know that the two acute angles are what we call complementary. They add to 90 degrees. So let's say the cosine of x is 7/25. Well, then that means the adjacent to x would have to be 7 and the hypotenuse would have to be 25, or some multiple of those numbers. So the sine of y is equal to the opposite over hypotenuse, which is also 7/25. So the cosine of one angle is equal to the value of the sine of its complement. Number 4, a 30-foot ladder leans up against a house and it makes a 75-degree angle with the ground. Okay, so here's the house, here's my ladder, 30 feet, and I want to know to the nearest tenth of a foot how far up the house will the ladder reach. So I am, in reference to the 75-degree angle, I'm looking for the opposite side, and I have the hypotenuse. So again, I'm going to use the sine of 75 equals opposite over hypotenuse. Once I've set my equation up, in order to solve it, I'm going to multiply both sides by 30, and I get 30 sine 75 is 28.9777. They told me to round to the nearest tenth of a foot, so the 7 would round the 9 up to a 0, which rounds the feet up to 29.0 feet. So that's how tall the ladder reaches on the house. All right, in the diagram below, number 5 says, oops, sorry about that. Triangle ABC is similar to DEF. Select all the true statements. So I know that similar triangles, corresponding angles are congruent to each other. So angle A is congruent to angle D, angle E is congruent to B is congruent to F. That's supposed to be a B. And so from here, I can just run through and check. Is the cosine of B, and you might want to just write SOHCAHTOA, wherever you like to keep track. Cosine of B. Cosine is adjacent to B, would be BC, and over the hypotenuse, which is AB. So that one checks out. Tangent of D. So looking at angle D, tangent is opposite over adjacent. So it should be EF over DF. But that's not what's on the answer here. So I know D corresponds with angle A. So angle A is opposite would be BC and adjacent would be AC. So that is not correct because that should have been AC to make it correct. Sine of E is opposite over adjacent, so DF, but that's not the letters they're giving me. They're giving me the sides from the other triangle. So I have to jump over to angle B since it's congruent to E, and sine is opposite, AC, over hypotenuse, which is BA, so that one checks out as well. Sine of B is DF, which goes with the other triangle, which means I have to look at sine of E, because B and E are congruent angles. DF over ED, opposite over hypotenuse, that checks out. Tangent A is opposite over adjacent, so that would be tangent A would be BC over AC, but they're giving me letters from the other triangle, so I need to go tangent A is equal to tangent of D because these are congruent angles. So tangent D would be EF over DF. Checks out. And then finally, cosine E is equal to adjacent over hypotenuse, but they're giving me the letters from the other triangle, so I have to go back to its congruent angle, which is B. E and B are congruent, so adjacent would be BC, hypotenuse is AB. That checks out as well. So 5 out of those 6 angles are all true. Number 6, in a right triangle, if the acute angles have the relationship sine 54 equals cosine 3x minus 9, what is the value of x? This goes up to the example up here above, that the value of sine of one angle is congruent to the cosine of its complement. So what I know is that the sine of one angle is congruent to the cosine of its complement. Well, that means that these two angles need to be complements of each other, and complementary angles add to 90 degrees. So what I can do is set an equation up, adding the two angles together and setting them equal to 90. I'm going to just combine like terms. So I have 54 minus 9 gives me 45. I'm going to subtract 45 from both sides, and I get 3x equals 45. Divide both sides by 3, and I get x equals 15. Okay, and if you wanted to check that in your calculator, you could do that as well. Oops. You could press sine 54, and you can do cosine 3 times 15 minus 9. And you confirm that both those values are in fact congruent to each other.